one. Grab a calculator, warm up. All right. So what's the name of that Greek letter with the vertical line through it? Phi. Good. So if phi is this huge angle, we want to find theta between 0 degrees and 360 degrees coterminal with it. Again, what does coterminal mean? Those two angles are coterminal if they share the same terminal ray. They land at the same spot. Good. So this is a negative angle. So what we'll do is we'll flush. Okay, we type it in -26578.31. Now, instead of adding back 360 repeatedly, right? Plus 360 plus 360, we said you could just divide by 360, boom, and that tells you how many rotations. Do I care about those first 73? Nah. So we add them back. Your goal is to make that whole number 0. So whatever that number is, you're going to do the opposite. -73. So I'm going to put plus 73, hit 0, boom, and now I get that. It's that fraction of a rotation. So it's about 82 hundredths of a rotation clockwise. I want to know what that translates to in degrees. So I'll remultiply by 360. And there you go. So now I'm going to write that one down. I know that an angle, I'm going to call it alpha, is -298.31 degrees. Is that the answer I want? No. Now, let's think about this. If this were a test question, guess what answer choice A might be? That angle right there, -298.31 degrees. Well, you would dismiss that one out of hand because if I say to find theta between 0 and 360, that one's negative. You'd be like, that's not an answer choice. Well, guess what else an answer choice would be? +298.31. And some of you might be like, that's the answer, right? I got that number. I just, maybe it wasn't supposed to be negative. I guess that's it. But that's not the answer either, is it? No. I want the angle that's one rotation away. Now, before I do it on the calculator, let's just see where this fellow lives, okay? -298.31. That is going to be a clockwise rotation from the positive axis. So there's -90, there's -180, this is -270, and then boom, it lives somewhere in here. That's alpha. What I'm looking for is theta, which is this angle, right? That's the one that's a counterclockwise rotation. Now, the magnitudes of alpha and what I called alpha and what I'm looking for theta, the magnitudes will always add up to 360, won't they? Always. So all you have to do, as I mentioned, if it starts as a negative angle, is to just add back one more full rotation. So plus 360. Okay, and you get theta equals 61.69 what? Degrees. Okay, the grubble has to be there. So 61.69 and -26578.31 and -298.31 are all what with each other? Coterminal. Okay, cool. Oh, we do. We do. Oh, yeah. 3 decimals always. This one truncated prior. Now, I'm not going to make you give your answer in DMS. I was going to quiz you over just converting from DMS to decimal and back again, showing me the conversions. But really, I'm not going to do that. It's going to take time. And I think that since the calculator can do it for you so easily, I'm not going to bother quizzing over that. But again, if this were an answer choice on the test, I might put those answers in DMS instead of decimal degrees. You would do the problem using decimal degrees, right? And then only at the very end, you would convert it. So once I found 61.69 decimal degrees, I can just hit answer, that's second negative, or type it in, right? Because it terminates. And then how are you going to get to the convert to DMS? Second apps, your angle menu. And then we're choosing which one? Number 4. So that would take your answer, bless you, from the previous line with all the decimals intact and convert it to DMS and say, so now it's say, or 61 degrees, 41 minutes, 24 seconds, right? So I'm not actually going to require you to show those conversions. I showed them to you because it's nice to know how it works. But since the calculator does it, we'll just let it do it. All right. Comments, questions on the warm-up? Comments, questions on status? Okay. We're on example 8, right? 6. Okay, that's close enough. All right. So let's go back to this warm-up that we just did. Angles are good and all, right? But in geometry, the angles that you studied first led to closed polygonal shapes, right? Closed polygons. So the closest or the earliest, the easiest, I should say, the most primitive polygon is what? The simplest polygon is what? How many sides? 3. You need at least 3 sides for a closed end polygon, at least 3. Okay, 2 doesn't quite cut it. So here's what we're going to do. We're going to always figure out where the angle lives within one rotation. I'm going to extend this ray out a little bit further. Okay, because that ray goes on indefinitely. And what we're going to do is we're going to create a triangle. Okay, here's how we're going to create a triangle. We're going to go to any convenient point on the terminal ray, any convenient point. I'll just call it that one. And we're going to let gravity take over. We're going to drop a perp. Okay, which sometimes means tackling a bad guy. Like if you're a cop, drop a perp. But in this case, we're gonna essentially draw an altitude. That's its formal name, but it's a perpendicular. We're gonna draw a line vertically to the closest x-axis. All right, now that's important. When we drop a perp, we drop it to the x-axis. That's our independent variable. We do not drop a perp to the y-axis. Okay, we do not draw a line straight across this way. No, no, no. It goes straight down. Now, what that does is it creates this little fellow right there. Okay. And we call this the reference triangle. Reference. Okay. I'll define it down below with words, but we call that the reference triangle. It's the triangle to which we will refer. All right. And that's when you have sine, cosine, and tangent, SOHCAHTOA. You had to remember establish a reference angle first. So it's one of the 2 angles that's not 90 degrees. And it varied, right? We're always going to then call this angle here at the bottom is now going to be called the reference angle. So in this case, the reference angle is the same as the coterminal angle. It's 61.69 degrees. Now, in geometry, in planar geometry, you could have actually referred to the top angle. You have another acute angle up there. We're not going to refer to that one ever as our reference angle. In planar geometry, when you use SOHCAHTOA, the opposite and the adjacent depend on which angle you're looking at, right? Let's just look at SOHCAHTOA. Let's just look at the first part. So that means sine is opposite over hypotenuse. If I use my reference angle, which is what we're going to be using, the opposite side is this, right? That's the side opposite. And of course, the hypotenuse is always this. But in planar geometry, you are allowed to use this angle. And now if that is the angle to which I refer, the opposite is now over here. See that? And the hypotenuse is still this one. So that's why it was important in geometry that you establish clearly which of those 2 angles that are not the right angle, because SOHCAHTOA only works with right angles, right triangles, which one are you referring to? Because the opposites and the adjacents are going to switch depending on which one. Well, guess what? We're doing coordinate geometry. We're systematizing the entire process. So guess which angle we're always going to call the reference angle? The one that is nestled up tightly, snug against the origin. Okay, never the one that's floating free up top. Never. Our reference angle is always going to be a positive acute angle. It's always going to be positive. It's a size. It's a positive acute angle between the terminal ray and the x-axis. Always. Okay. Now, the reason that we want to create a triangle and talk about the reference angle is so that we can start talking about ratios of side lengths, one to the other. And that's your trig ratios. That's your SOHCAHTOA. Now, it doesn't matter from where you drop the perp. Okay, let's just look at that. What if What if your neighbor dropped the perp from further out? Okay, their triangle is going to be bigger. But what do we know then about the purple triangle created and the blue triangle that I shaded? Are they proportional to each other? Similar triangles, right? They're similar because of side angle side. You don't have to know all that right now, but they are similar triangles. They're proportional to each other. So when I take the ratio of sine opposite to hypotenuse, that scale factor will always divide out. Okay. So if the purple one is twice as big, all the sides are twice as big. And when you take the ratio of opposite to hypotenuse, that scale factor of 2 always divides out. So it doesn't matter eventually if we drop a perp from way out far or way too close. You just want to drop it from a place that gives you some room to write things inside your triangle. Okay. So let's go ahead and define it. Definition: a reference angle, which usually I put a subscript on it, theta subscript REF, is a positive acute angle that measures the rotation. Okay. That's the measure of the angle of rotation between the terminal ray and the closest x-axis. Okay. Now, can a reference angle be negative? No, it says right here it's positive. So a reference angle, unlike an angle in standard position, is a scalar quantity, not a vector. Every other angle in standard position, remember, is a vector. The sign tells you which way you're rotating. But a reference angle is just a magnitude, okay? It's just a magnitude. Or size only. That's why it's always positive. And it's always acute. True or false? A reference angle can be obtuse. False, okay? False. It's got to be acute. So it's going to be between 0 and 90. And it always measures the angle between the terminal ray and which axis? The x-axis, your independent variable. So you're always going to look nestled up against the origin, all right? Let's look at the 3 cases, all right? Or 4 cases. There are 4 cases. Okay, so let's draw 4 right up here at the top. Let's just draw 4 little x and y axes. I'm going to copy that once. Copy, paste, paste, paste. Yummy paste, right? They had to make paste non-toxic and edible because elementary kids like to eat paste, supposedly, right? All right, if my angle terminates in quadrant 1, okay, if theta terminates in quadrant 1, and I'm going to say between 0 and 360, so it doesn't go around many times, then in this case, theta is the same as the reference angle. That's like the one we just saw. Okay, if it terminates in quadrant 1, you find theta to be a positive acute angle between 0 and 360. That's the same as the reference angle. Okay. What if my angle theta terminates over here? Here's theta. Theta gets me into quadrant 2. How do I find the reference angle? Well, let's identify the reference angle first. Okay, it was the same over here. Over here, here's the reference angle, right? This is the reference angle. It's the measure between the terminal ray and the closest x-axis. So in this case, is the reference angle the same as the angle? No, they're not the same now. But based upon what I know, how can I find the reference angle if I know theta? 180 degrees, right? Minus what? Theta. Good. We're stopping short of 180. So the difference between 180 and the terminal ray will give you the reference angle. And that makes sure it's positive. 180 is bigger than theta, right? Because theta is smaller than 180. So we do big minus small to make sure it's positive.
Now if it goes into the third quadrant.
Yeah, let's draw that. Let's draw that, Brady. So this would be, let me go ahead. Let me label this. This is when it terminated in quadrant 1. This is if it terminates in quadrant 2. Let's draw one. Yeah, it goes all the way around. Let's have it terminate in quadrant 3. So there's theta. Now, what's the reference angle? The reference angle is this piece right here. That's theta ref. So in this case, is the reference angle the same as theta? Not kind of. Theta is between 180 and 270, like 225, right? That's a possible measure. 180 plus another 45, that could be 225 degrees. Does that mean the reference angle is 225 degrees? No, that's way obtuse, right? If it's bigger than 180, we call it a reflex angle. But I know the reference angle is this little piece right here, the size of that angle. Again, if you know that the x-axis is 180 in this case, and you know what theta is, instead of doing 180 minus theta, I'm going to do what? Theta minus 180, because now theta is bigger. This is why it's so important to draw the picture. I can clearly see theta went past 180. So now the reference angle is the bigger part, theta, minus 180. And by the way, this works the other way around. If you know the reference angle, you can find theta by adding it back to 180, right? Just manipulate that equation. Quadrant 4, if it goes into quadrant 4, let's draw that. And again, I'm just kind of drawing a random, like almost on a 45 degrees. There's theta. And what's the reference angle? This is the reference angle right here. And how do we find the reference angle now? Is it the same as theta? No. Theta minus 360? Not quite. Which one's bigger, 360 or theta? 360 minus theta. So now we're not working off 180 like we did in quadrant 2 and 3. Now we got to work off the positive x-axis. So now we're short of a full rotation. So now it's 360 degrees minus theta. Okay. You don't have to memorize that, because if you're drawing your picture correctly, you can just work off the x-axis. Now notice again where I drew the reference angle. It's always between the x-axis and the terminal ray. Sometimes people want to find the other little angle between the y-axis and there, and you can, but that's not our reference angle. Okay, we're systematizing it, so it's always the one, we call it a central angle by the origin. All right. And of course, all you need to do to create a reference triangle is to drop a perpendicular, right? Let me go back through and do that. If I come up here and drop a perp, I create a reference triangle. If I come over here and drop a perp, I create a reference triangle. Now over here, we have to go against gravity. I drop a perp going up, right? I see people trip up the stairs every day, so you can go against gravity. And then over here, if I drop a perp upward, or you could drop it from the x-axis to the terminal ray, whatever. That's going to create a little reference triangle. Okay. So the reference triangle and the reference angle pretty much referring to the same thing. The reference triangle just gives you a side length so you can have a three-dimensional object. All right. Can theta be negative? Can an angle in general in this class now be negative in coordinate standard position geometry? Can we have a negative angle?
It's not a reference angle, then
yes, right, good, because the negative angle just means that we're rotating from the positive x-axis clockwise, right? But can a reference angle be negative? No, a reference angle is a scalar quantity. It's a magnitude only, all right? And it's always acute. Okay, let's try example 6. Example 6. If beta is negative 265.363, part A, draw it in standard form, okay, or standard position, either one. All right, so let's do that. We're going to need ourselves a y-axis and an x-axis, and I'll use green, okay? So now I'm starting somewhere over here on the positive x-axis. You don't have to draw the initial ray. I'm rotating which direction, clockwise or counterclockwise? Clockwise, okay? Now it's good to know when you hit the x or y axis how many degrees that is, right? It's 90, 180, and then 3/4 of the way around is 270. So that 270 you should get familiar with, right? 0, 90, 180, 270, 360, right? So if you want to label it, here's 0 degrees, here's negative 90 degrees, here's negative 180 degrees. This would be negative 270 degrees, and then all the way around would be negative 360 degrees. If you know what those angles are, and that's pretty intuitive, right? Maybe 270 you didn't use a lot, but if you know that that's the measure of rotation to the x and y axis, That helps you land in the right quadrant, doesn't it? We're just going clockwise. So negative 265 is going to live in which quadrant? 2, right? So we're rotating. Here's negative 90. Here's negative 180. And we're stopping short of negative 270. So somewhere right here. There we go. And now I'm going to label that as bubba beta, either inside the arc or outside the arc. So I know which one I'm referring to, right? Now, that's not usually the angle that I want. I always want the coterminal angle that's between 0 and 360. So that's the next part. Part B, well, part B, find the reference angle. Okay, let me draw the reference angle. Is this the reference angle right here? No, the reference angle is this one. This one is beta sub ref. Okay. Now, how can I find it? Now, I got to be careful. If I do beta minus 180, beta is a negative number. If I do a negative number, minus 180,
plus 180.
but if I do theta plus 180, that's still going to give me a negative angle, isn't it? So here's where you have to kind of like jettison or abandon the negative. The negative just tells you which way to rotate. Now I want to work with scalar quantities. I want to work with magnitudes. I rotated by 265.363 degrees. Yes, that's the magnitude. And I went past 180. I want to know how far past 180 I went. So I'm just going to say that this is going to be positive 265.363, or in other words, the absolute value of the angle. And then I'm going to subtract 180 from it. Okay. So when you're finding reference angles, it's easier if you just work with the scalar quantity. Now let's see what that gives us. Over here to the calculator, positive 265.363 minus 180. I went past 180, and there it is. It's equal to 85.363. Now that's labeled, right? It says beta sub ref. So let's just make sure of two things before I walk away from the reference angle. First of all, is it positive?
Yes.
Yes. Is it acute? Yes, between 0 and 90. Okay. So you're good. If you actually did it reversed, if you did 180 plus negative 265 and you got a negative number here and then you just erase the negative, you're going to lose points. So you either come back and fix it by putting absolute values around it, or you just come back and rewrite it. Big minus small. Okay. Once we establish the rotation, which direction, and we landed a terminal array, we want to work with scalar quantities. Okay. Now it says to find the coterminal angle, the beta, and notice how I'm writing that, beta subscript cot. I want to find the angle that's coterminal to beta, that's 47 rotations away, positive rotations. Okay, well, how am I going to do that? Here's how I find it. Beta coterminal. If I want it to be 47 positive rotations away from beta, I'm not going to draw that. I'm going to take beta, and how do I rotate in the positive direction? Do I add multiples of 360 or subtract them? If I'm rotating in the positive direction, I'm adding them, right? So I'm going to add 47 multiples of 360 degrees. If I wanted it to be 47 clockwise rotations away, I would have subtracted 47 times 360. Why 47 times 360? That's, yeah, that's an easy one, right? Y'all, that's intuitive. You're like, duh, right? Each rotation is 360. I want 47 of them. 47 times 360 gives me the magnitude of the rotation. I'm adding them because I'm rotating in the positive counterclockwise direction, and I'm adding it straight to beta, which is a negative number. We're starting at negative 265, and I'm going 47 around. So now we can go straight to the calculator. Negative 265.363. Why am I using the negative here and not the positive? Because it says it needs to be 47 positive rotations away from beta. All right. And so now I just say plus 47 times 360 and hit boom. And there it is. That coterminal angle is 16654.637 degrubbles. That one is certainly coterminal with our original angle. All right. It says to convert them all into DMS. I don't think we need to do that, right? Let's just convert this one into DMS since it's still on the screen. To convert this to DMS, I just go second negative, right? I'm going to recall the answer in its full decimal glory. This one truncates. And then I go second apps, number 4, go to the angle menu and hit enter. And you're going to get 16,654 degrees, 38 minutes, and 13.2 seconds. Those are equivalent. Okay, so that can show up as an answer choice, right? I still prefer decimal degrees. Now let's do one last thing. I should probably add this too here. Let's go ahead and find the angle that's in our comfort zone. This is the one that I'm always going to be interested in, aside from the reference angle. What is the positive angle between 0 degrees and 360 degrees that gets me to that same terminal ray? That's the one that we have the most appreciation for. How can I find it? Well, first of all, let's name that. Let's name that alpha. Now, again, your picture tells you exactly what you need to do. How do I find alpha? Well, isn't alpha just one rotation away from beta? Beta plus one rotation. Yeah. So instead of adding 47 rotations to beta, let's just add one rotation to beta. Negative 265.363, and I'll just add 360 to it. Okay. And there it is. So now alpha is 94.637. Is that reasonable based upon our diagram? Does that still terminate in quadrant 2? Yeah, I go up to 90 straight up and then a little 4.367 degrees past. Okay. Now, what if we didn't know the reference angle? We found it by looking back. What if I knew that alpha was 94.637? How could I use 94.637 to find the reference angle? Subtract it from what? 180, because now that angle didn't go past 180. It stopped short of 180. So look, we could find the reference angle another way, 180 minus the answer. And you get 80, is that the same one? 85.363. Yeah. So there's going to be a lot of different ways to get your answers. That's why the diagram is so important. The most important thing is to figure out for any given angle, where does it terminate? And that's why we did those big angles first. Where does it terminate? In which quadrant does it terminate? If you know that, and the measure of rotation that gets you there within one rotation, whether it's negative between 0 and negative 360 and 0 or positive, you can find the reference angle. And if you know the reference angle, you can find the actual angle. And if you know the actual angle, you can find the reference angle. You draw the picture and you work off the x-axis, right? Either 0, 180, and 360. That's it. You don't have to memorize anything. You just work off your diagram. All right. Let's try another one. Okay, we'll call this a bonus number 5. Bonus number 6, I guess. Bonus number 6. I'm going to give you phi to be 38764.92 degrees. I want you to find, first of all, find the coterminal angle. That's between 0 degrees and 360. This is another way to write it. And then B, find the reference angle for beta. There's only one reference angle. All those coterminal angles, they have the exact same reference angle. Did y'all know that? Every single coterminal angle, which there's infinitely many of them, they all have the exact same reference angle. There's only one reference angle. Okay. So how are we going to do this one? Well, it's a large angle. It's positive, right? Finding this piece here, what is the coterminal angle that lives between 0 and 360? That's the most important part. I want to figure out which quadrant does this guy live. So we need to kind of get rid of the full rotations, don't we? So here we go, 38764.92. I'm going to divide that by 360. Boom. I'm going to subtract out the full rotations, 107, boom. And then I'm going to remultiply by 360, boom. And I get phi coterminal is 244.92 degrees. This makes good quiz question material, okay? And here's the deal. You don't have to show me those tedious calculations on your paper. You can do that all strictly on your calculator, all right? You know what to do. Divide by 360, get rid of the whole number part, remultiply by 60. Now, if this started as a negative angle, this would still be a negative number, right? I'd have to do that one last thing, add one more rotation to it, plus 360. But if I start with a positive angle, have a positive angle, okay? Once you find that positive angle between 0 and 360, now you're going to sketch that angle in standard position, right? So let's go ahead and sketch it. Even if I don't ask you to sketch it, I'm going to expect you to sketch it. In fact, I'm going to give you a check for sketching it, even if I don't ask for it. It is an automatic thing that you instinctually do every time. 244.92. Which quadrant does that live in? 244.92? Quadrant 3? Good. So we're going counterclockwise. There's 90, 180, 270 is all the way around, so it's stopping right here. So there's phi coterminal. And now it's inchoate, right? Now it's rudimentary. Now it's fundamental. By the way, the word of the day is inchoate. It's a great word. Inchoate is an adjective that means something that is rudimentary, something that's very basic, something that is in the process of being formed. It's one of the fundamental foundations. It's rudimentary, it's inchoate, right? If you get a jury summons, sometimes you have to give up work and you have to spend the day inchoate, right? In court. Yeah, that's funny. Okay. So let's go ahead and find the reference angle now. This is the reference angle right here. That's the reference angle. So how do we find it? Now we're working with scalar quantities. To find the reference angle, what do? I'm in quadrant 3. Did I go past 180 or did I stop short of 180? I went past 180 by a smidgen. I want to know by how much did I go past 180? So I take the angle that got me there, which was 244.92, and I subtract 180 from it, okay? So I'll write it out here. It's going to be 244.92 degrees minus 180 degrees, which equals, well, I can just hit minus 180 on my calculator. Boom. I typed it in wrong. 244.92. How did I know that was the wrong answer? I typed in minus 18, forgot the 0, and got 226.92. If I'd have written that down, I would have got it wrong. But if I'd have written that down, I shouldn't have, right? Because that's not an acute answer. So I forgot the 0. Hit enter. There it is, 64.92 degrees. There's the reference angle. Okay. And notice how it's clearly labeled. We're using the subscript notation now. So instead of giving them their own name like phi and alpha and beta, we're using subscripts like Kevin Senior, Kevin Junior, Kevin the Third, right? We got phi subscript coterminal, phi subscript reference angle. Got it? Now, what if I wanted to find the coterminal angle that I have drawn there? I should label it, right? Oh, I did. I labeled it down here. What if I wanted to find phi coterminal, but I knew the reference angle only, 64.92? Can I use the reference angle to help me get the coterminal? Yeah, it'll be 180 plus the reference angle. So again, if you know one of them, you know the other, right? It's the same equation. You're just solving for the other one. If you know the reference angle, you can find the coterminal between 0 and 360 and vice versa.
It's high. Well, you can't find phi.
Why can't I find phi? All right, we're done. Go ahead and clear your calculators. Tomorrow we're going to learn about, tomorrow we might quiz over this, by the way. So be ready to go. I'll give you like a negative huge angle in degrees, a positive huge angle in degrees, and I'll have you find the coterminal between 0 and 360. I'll have you sketch it, and then I'll have you find the reference angle for 2 different angles, one huge negative, one huge positive. And you're welcome to use my calculator Medors. Is that good? Y'all can do that, right? Free hundreds, yum. Amelia Earhart, aviator of the day. Yeah. She might have. Kristen McAuliffe. All right. And happy birthday once again to Estão